Don Eisele, tell us about yourself. Where are you born?
I was born in Columbus, Ohio, Rhett. I was born and raised there, and then I went to the Naval Academy, and following that I went into the Air Force. I've been in the Air Force about 16 years now. I've been with NASA 5 of those years, and before that I was a test pilot in Albuquerque at Kirtland Air Base.
Air Force.
Mm-hmm.
What sort of planes did you fly at?
At Albuquerque we were flying F-104s and F-100s and one old B-57 we had there to do some special projects with.
Mm-hmm.
It was a very interesting assignment.
Then when did you join the space program?
In 1963. Late
You were
63 we were selected.
In the 3rd group of astronauts selected,
That's right.
And you've been working on Apollo 7 now for how long?
A little over a year.
When you were assigned to this crew?
That's right.
Mm-hmm.
Of course, Wally and I have been together now for, well over 2 years. We, at one point, had what was then to be the 2nd Apollo flight. That was eliminated because of program considerations, and we were then reassigned as a backup to the 204 crew.
Mm-hmm.
And then after that accident, we were assigned to this one as prime crew. So it's kind of been off again, on again, and we've been together now for, well over 2 years.
Is your wife an Ohioan?
Yes, she's from Ohio.
And how many children you have? What
Well,
age?
we have 3. I have a daughter 14, a son 12, and a son 3.
How do they look upon the space program? Are they enthusiasts?
Well, I think they're so close to it that it doesn't have the uniqueness or the aura of excitement that perhaps it does to someone who's just... It's the same thing as people who live in New York City and never go see the Statue of Liberty. You know, it's there and they're used to it, and so they're, if anything, I guess a little blasé about the program.
I thought you were going to say, so what, as their reaction when you stop to think about it there. But children so close to it around Manned Spacecraft Center live it all the time.
To a great degree. Yes, that does not mean they're disinterested. It just means that they've learned to accept it, and it's not a great big thing to them, you know.
I'm sure there are children and young people all over the world listening to us right now who would love to be here and to watch you take off and to be talking to you right now, too.
I expect that's true. No, my children are interested in what I'm doing, just as any kids are and what their fathers are doing day to day, and I've tried on occasion to show mine what I've done. I've taken them down to Florida and shown them the Cape there, and they've been through the facilities here at MSC a number of times, and I try to explain to them as best I can what I do each day. So in this matter, I try to at least keep them posted on what their old man does.
Don, what do you do on this flight as command module pilot?
Well, on this mission, I'm the navigator primarily, responsible for operating the guidance system and all the associated equipment. We've been looking at them in the simulator. We have actually an excellent representation of the celestial sphere in the simulator through the windows and through the optic system. Look just like real stars. We also get a lot of star practice flying at night, because we're usually at a high enough altitude that we're above any weather that's around, and you can see at least one half of the sphere up there. We've gotten a lot of good training just by gawking at stars as we fly along.
Do you take a sextant with you on these T-38s?
No, we don't have any need or use for a handheld sextant. The sextant in the spacecraft is built into the vehicle, and it's mounted very solidly to what's called a navigation base. It's a massive piece of machined beryllium, I believe, or some similar metal, and the whole system is bolted to that, and it's operated electrically with certain controls that you use. So it's not the classic sextant operation like you would do in an aircraft or a ship. In some systems checks. One in particular we're concerned about is cabin pressure relief. At a certain time after liftoff, 46 seconds to be exact, we expect the cabin relief valves to pop, and you can hear them when they do this, and some of the air start relieving out of the cabin because you're getting into regions of lower pressure.
So you're going from 16 pounds down to about 5 or something?
Yeah, ultimately as you go higher and higher, you bleed down to 5 or 6 pounds cabin pressure. If the cabin pressure does not relieve within a short time, you may be in a situation such that if you had to abort, you could have a possible damage to the pressure vessel. So if we perceive that we're not relieving the pressure at the right time, we'll call to Wally to open the cabin dump valve manually. He has a lever over there that he can pull which manually opens these relief valves. And as a backup to that, there's a dump valve in the hatch right behind my shoulder that in a pinch I can reach back and open that one. So we're covered about 3 ways on that.
And you've rehearsed
But I'd say
this
this is an example of something that we've had to work out the coordination and the procedures on it. Yeah.
And you've rehearsed it to the point where you're ready for that eventuality.
Yeah, it's part of the little routine we go through on the launch.
And after the booster gets you up and into orbit, what will you then be doing?
The first hour or so we'll remain strapped in our seats, checking systems, running through some post-insertion checklist items to be sure that all the equipment on board is working the way it should, that we don't have any failures or incipient malfunctions that would cause us to have to come down prematurely. In other words, we want to make sure that we're good and safe before we start unstrapping, because we have to come back in a hurry. We don't want to have to worry about the strapping in again. That's quite an exercise. So after the first hour, when things look good, I will get out of the couch and go down into what we call a lower equipment bay. This is where the navigation equipment is located, and as well as a lot of stowed items. And we hope to remove our helmets and gloves at that time, go at a partial suited mode, and I'll stow some things and unstow some things that we need to continue the first several hours of the mission. Cameras in particular.
Boy, this one's a lot more roomy than Gemini.
Oh, it sure is. Yes, it is.
You can move around. You can get out of your seat.
Yeah, you have to, in fact, to get at this stuff. And one of the main things I'll be unpacking are the movie camera and the still camera, and we'll hand those to Walt and Wally. Then this is in preparation of the separation from the booster. You see, at this time we are still attached to the S4B, and we will be for about 3 hours. At the end of the second revolution, we will separate, turn around, and Wally will do a simulated docking exercise and station keeping. And at that time, we'll take some pictures. Walt will probably take most of the pictures because Wally's busy flying, and I don't have a good view of the booster from the window I have. So then after a limited amount of station keeping, we'll separate from the booster and begin some systems verification tests and some of the test objectives on the flight, and all prepared to assess the spacecraft condition so that we can get a go to proceed for the first full day of the mission.
Don, as the navigator of Apollo 7, you're going to be exercising some interesting equipment and participating in some sophisticated methods of space navigation, which have never been done by man before. I think our listeners around the world would like to hear about some of the equipment you're going to use and some of the navigation that's to be accomplished on Apollo 7.
Well, I might start out by describing the guidance system that we have on board, the guidance and navigation system. It consists of 3 main components. There is a computer, there's an inertial platform, and an optics system, and these are used in conjunction with each other to perform the guidance and navigation functions. The computer, of course, I guess is the heart of the whole thing. It acts as a data processor and desk calculator, and also as an autopilot. It's also a control device. The inertial platform is very similar to what's been used for a long time on other spacecraft and on missiles.
Now, what are the instruments that you will be using in shooting stars and so forth?
Well, we have a sextant and a telescope that use together. The main difference between the two really is the fact that the telescope is only 1 power. It's not really a telescope in the sense of magnification. It's simply a window to look through in that sense. It has a fairly large field of view, about 90 degrees altogether. It can be manipulated and moved around to give 90 degrees field of view. The sextant is 1.8 degree field of view, and it has a 28 power magnification. And the idea is that you look through the telescope and look at stars and try to recognize a pattern or constellation, and then from that pick out a star which is designated an Apollo star, which means that it is listed in the star catalog in the computer. And once you've identified at least 2 of these stars, then you try to put first one and then the other into the sextant field of view. And you can move the sextant and telescope around in unison with a little electrical control switch. Once you get a star in the center of the sextant, you punch a mark button, and that the computer then at that point reads out these angles on the sextant and also reads your inertial angles reference to the inertial platform. And the purpose of all this is, first of all, if you do not have the platform aligned, you can do this when you're first starting up an exercise to get some alignment, some known inertial reference in space. If you already have an inertial reference, you can use this same method to move the IMU around to some preferred alignment, which you might want for a particular exercise, such as an SPS burn, a main propulsion system burn. That's part of the operation, the IMU alignments.
Why does it take so long to set up the guidance and navigation system to get it aligned? Why does it take several hours?
Well, it really doesn't. We have just provided in the flight plan for 2 night passes before any major exercise, such as a burn, to cover the case where you might not get it all done the first pass. And the main variable here, at least from what I've seen in a simulator, is just how well you can recognize the stars when you first look out there. If you're lucky, or if you're skilled and you recognize some Apollo stars right off, it's easy. You just go and put the sextant on them and hit the mark button, and in 5 or 10 minutes you've got a pretty good platform alignment. You may not be able to do that. You may have to search around the skies. You may have to maneuver the spacecraft to look at another portion of the sky. You may find out that you're looking down at the Earth when you first peer into the thing. And we're planning on doing all this during night passes when the sun's on the other side of the Earth. Now, there are some people who maintain stoutly that you can see stars in the daytime through this equipment. One of the main objectives of our flight is to find out whether you can. But we're taking a conservative approach and saying that since we don't know for sure, that we're not going to plan to do any critical alignments during daylight.
I think the most fascinating aspect of this whole subject of space navigation, Don, is the fact that you are now beginning to use the equipment, which is to be the primary method for navigating to another body in space and back in Apollo. And this is quite possibly the type of navigation which will be used for interplanetary travel by men in the future. Doesn't that sort of get to you sometime? Or are you just or is the engineer and you say, well, it's another piece of equipment?
Well, that too, but no, I'm aware that this is the first time. It's a new device, a new first in that sense. First time we've had a system of this sort on a spacecraft. And there are lots of questions. I have a lot of people looking on what we do. All of us actually be taking part in this sort of exercise with great interest. I'd like to point out further, we're discussing alignments. That doesn't really navigate for you. That just lines up the platform. We do have a system of navigating on board, which means using the same optical equipment and sighting on Earth landmarks. We have about 300 designated Earth landmarks, ends of peninsulas, runway intersections, this sort of thing that we use. We have a catalog of those with pictures and maps of the whole thing. And by taking marks on these landmarks, you can actually have the computer calculate your position over the Earth in latitude and longitude and your altitude. And from this it can determine what orbit you're in. This is the onboard nav system, very similar to what will be used on lunar flights. And there again, a great many people are vitally interested on how this turns out, because the onboard system is a complement to the deep space network of tracking stations that we have. And of course that will be, the deep space network will be probably the preferred method of navigating to the vicinity of the moon. But in case you don't get that data from them, or in lunar orbit in the vicinity of the moon, the onboard does become prime. So it's quite critical to find out how it works.
Don, you are command module pilot on Apollo 7.
Yes,
now,
sir.
Is this the same sort of function that command module pilots will carry out in other missions, including the mission to the moon?
Well, there is a difference in assigned tasks between our flight and the one subsequent to ours, which will have lunar modules assigned to them. On a lunar landing mission where you have a LEM, or on an Earth orbit, whichever, if there's a LEM attached, the commander and the LEM pilot, of course, will concentrate mainly on the LEM because it's really from an operational point of view, a more complicated exercise to get into the LEM and operate all the systems and run it the way it should be run. So that leaves the command module pilot pretty much alone as far as mastering all the inner workings of that vehicle. Now, on our flight, since we do not have a LEM, we can concentrate 3 people on these different systems, and we have tended to parcel out the duties so that each of us has certain specialties. We have, however, undertaken a great degree of overlap in our training, and in the interest of effecting better crew coordination, and also so that we can relieve each other at these various tasks.
Mm-hmm.
And so I guess the main difference is a matter of degree to which I would overlap into the other seats. On a lunar mission, I would be doing practically all of it, I suppose. On this flight, I'm doing mainly the navigation with a little bit of systems work and a little bit of flight control and commander's functions.
The command module pilot is the man who stays there in the Apollo spacecraft while 2 others go down to the moon and back in a lunar mission.
Mm-hmm.
Thanks very much, Don Eisele.
You're welcome.